Hello. Let's solve Leetcode 269 Alien Dictionary. Um, this question is saying that we've gotten a list of words, alien words, that have been already arranged in a lexicographical order. Now, they want us to also find a relationship between each of the characters and order them in a lexicographical order or alphabetical order if you put it that way. So the first example that we have been given is words of WRT, WRF, RER, ETT, and then RFTT. Right. From a first look at it, we can see these ones, right? WWEER. And if this has been arranged in a lexicographical order, another way we can just from sight know that W comes before E and E comes before R, right? Now if we take these two, we can also see that WRT, is it F? Yeah, WRT and WRF. We have the first two that are the same, which means T comes before F. So we can say T comes before F, right? And then when we come in here, we have ER and then ETT. These two are the same. We can see that R comes before T, so R comes before T. Now we consider there is a relationship, right? We have R here, we have R here, we have T here, we have T here. So this can actually be represented as a graph. And let's see how we can do that. So we have W here, W goes to E, and we know that E goes to R, and then R goes to T. We also know that T goes to F. Right? Basically, and as we can see from here, this is the answer, right? The answer is WERTF. Right? If we look at it from here, W goes E, E goes R, R goes T, T goes F. We have WERFT. Right? And anytime we have been given a graph to sort, we can use topological sort. Now there are a few edge cases that we should take into consideration, right? For example, if we have a word like, if we have arrangements like this, right? This is not possible because apple should not come before up. So if the second word is the starts of the first word, then it's not possible to arrange this kind of relationship. So that's something we should know. Another thing that we should know is what I've already pointed out. If these ones are the same, the next one is what points out. So let's look at the second example. The second example says Z and X. So we have Z here and it goes to X. So we have ZX. That makes sense? The last example is ZXZ. So we have Z that goes to X, and at the same time X goes to Z. So this is a cycle, and we do not we cannot handle that. So this kind of puts the question into a much more closer perspective, and it's a graph that we have to solve. Clearly we can see that the in degrees of this is 1, the in degree for this is 1 as well, the in degree for this is 1, and then the in degree for this is 1. This is 0. Right, so when we form the in degree for each of the letters in here, we can clearly start from here and then traverse the graph, then we can get that. So let's see how we can solve that in Leetcode. So let's form our graph. Let's form our in degree. Word in words, for character in words. Alright. So for I in range, length of word, -1. Word 1 and word 2 is equal to words I and words I plus 1. For first character and second character in zip, word 1 and word 2. Again, we're just picking these two words and then iterating over each of them, just like we are doing here to find the first one, right? If these two are not the same, it means the first one comes before. For example, if these two are not the same, which means that this one comes before this one. And that is exactly what we are trying to implement here. We have if first character is not equal to second character, and if second character not in the value of first character. Then graph of first character dot add second character, and then the in degree of second character increases by 1. Right? Then we break. There's no need to continue. Else, now we deal with this edge case example that I gave here, this apple and app scenario. If the length of word 2 is less than length of word 1, return an empty string. So now we have formed our graph. That's the first part of topological sorting. The next part will to set up our queue for character in degree. if in degree of character is equal to 0, we add it to the queue. And that reminds me, I have not set up my queue. So we have queue is equal to the queue. So now we have set up all the graphs with in degree of 0, put that into the queue. Now we can do our breadth-first search. So while queue, let's get our results too. While queue C is equal to Q dot left. Okay. Let's append that to the results. For neighbor in graph C in degree, taking 1 out of the in degree. Because we've already popped that out of the queue and we've examined it, so anything that is linked to all of its neighbor is going to drop an in degree by 1. If the neighbor's in degree becomes 0, Q dot append neighbor. So we are done with our breadth-first search. Now the next thing is deal with cycles. So if the length of the results is less than the length of in degree, you return an empty string. It's a cycle and we cannot deal with that. This is a cycle. We set up in degrees, this is just 2. The results should be 3, but it's just 2, so we handle that. Else, return our results of joining all the elements in the array. Yeah, this is a long one. Okay, let's see how this turns out if I have not missed anything or typed. Yes, I knew it. So first word in list, word 1, word 2, what's it saying? Invalid syntax. Always 4. Q is spelled wrong here. Q dot pop left. Awesome. Alright, so what I missed was this was a for loop, but I put an if statement here and I spelled Q incorrectly here, so that's why. Alright, this is it. Look into topological sorts. See you in the next one.